Hello everyone, welcome to all of you my class. This is Mehdi Hassan, your online instructor. Today in this video we are going to start our new lesson which is the Digital Electronics Lab. This lecture will conducted by me Mehdi Hassan, Electrical Engineer, Department of Electrical and Electronic Engineering. Okay, now we are going to start our topic. In this playlist you can find all of the course related this digital electronics. So let's start. So first of all we are going to see some basic components here. This is a breadboard where we can mount different types of ICs and can successfully develop any project. We need some ICs, but the internal diagram of IC are like that, but basically the IC are look like here. We are going to develop all of our simulation project on Proteus 8. We are going to see about that, but first of all we have to recognize some ICs to increase our system. Okay, so first of all here is the experiment number 1, where the name of the experiment is implementation of Boolean function using logic gate. That means we have to implement the Boolean function by using some basic logic gate. Boolean function Boolean function say that the different types of ICs can do different types of work. So first of all the AND operation. AND operation means the product or multiply system between the high output and low output. Okay, and then OR gate means the addition output between low or high input, and it's depend about the input at output. And not gate means the inverter, where if the input is low the output will be high, and if the output will be low then input will be high. Basically the output will depend on input and it is going to invert. These three gates are basic logic gate, and we develop different types of gate and ICs by using AND, OR and NOT gate. So here are different types of gate. You can see here XOR gate, NAND gate. NAND gate means NOT gate and AND gate mixer. NOR gate means NOT gate and OR gate mixer. They are called a special gate. XNOR gate and XOR gate is known as exclusive gate. Okay, so we have to remember some IC's number, where the IC number 7408 means AND gate. The symbol diagram like here, but the pin system is here. We can see that our input will be go at terminal 1 and 2, and our output will be found at terminal 3. A 7408 IC can handle 4 AND gate. We can see here. We have to remember that 7432 IC means OR gate, and the symbolic diagram is like here, and there are 4 OR gate operation we can find our 7432 IC. Basically all of the ICs has 14 terminal. The number of 14 pin is connected to through VCC or plus input, and the terminal 7 is connected with the negative VCC or minus input. Basically the ICs can operate at the voltage of 5 volt. We should not get more than 5 volt. We have to use them around 4.5 volt to 5 volt. So the NOT gate IC number is 7404, and it is an inverter gate. Basically we can remember the inverter gate by see this symbol just here, the bubble. If the bubble is found anywhere, then the output will be invert towards the input. There are different type of ICs are looking here. So we are going to see our next operation at Proteus. Here is the Proteus software. You can install it in your desktop or laptop and you can easily use it. So first of all, our experiment is calling that to develop a circuit diagram where f is equal ab plus cd whole invert. Basically, it says that the terminal a and b will be multiplied together and c and d also multiplied together, but the product of ab and cd will be addition here, and after the whole result will be invert. If the output is 1, then it have to invert as like 0, and if the output will be 0, then our final output will be invert and we can get 1. Okay, so first of all, here we can see the addition and multiplication. For multiplication we use AND gate, and the IC number of AND gate is 7408. You can see from here the AND gate IC number 7408, and we have to use a addition system for using OR gate. The IC number of OR gate is 7402, sorry 7432. So oh, and we get another NOT gate. The NOT gate IC number is 7404. So basically we can use 3 gate here. Okay, now we are going to clear our project. So let's get started. So we have to call some IC 7404. This is for NOT gate. Here it is the NOT gate, and we need 7408. This is for AND gate, and we need 7432. This is for OR gate. We also need some logic state. And we need some logic probe. Logic probe means this is the output showing us that it is the output 0 or 1. To see some exclusive output, we can use also green LED. If the green LED glow, we can say that our output is 1, and if this is not, then our output will be 0. But we can see by using also logic probe. So first of all, we have to making AB and CD, and then addition them, and at least we have to invert them. So first of all, if we want to make AB here, so we need an AND gate. Although there are two operations of AB and CD, so we need here terminal 2, and we are using some logic state. We can rename it. We can rename it here. We name it at C and it rename at D. Okay, so now we are going to connect with the ICs here. So our output AB and CD will be found at the output of AND gate. So our AB and CD output will be found here, and we have to make addition of them. So to make addition, we are using OR gate here, and connecting both of the input of OR gate with the AND gate, and here the output of OR gate will show us the ultimate output of AB plus CD, and we have to invert them. So if we want to invert them, we must use our inverter gate, which is NOT gate. Basically, if you want to see here the output at digital number, then you can use the logic probe here, and if you want to see by using LED here, you can use also LED here. But if you have to see this in LED, you also need a ground to see the actual result. Now we run them. You can see that if our A is 0 and B, C, D, all of them are 1, so our output will be 0 here, and LED is not going to be green. And if we are using all of the terminal 1, also our output will be 0. And if we use all of the output as 0, then our output will be 1 and delta will be grow here. So first of the experiment has been completed here. Our Boolean expression has been proved. Okay, there are 4 input here. We can see the 4 input can make combination of 16 output. 2 to the power n is the equation here. So we can put the value of n is equal the number of input. So 2 to the power n means 2 to the power 4, that means 16. So you can rewrite the truth table from here, that if the all the input are 0, then what will be the output. We can see here, if all of the input are 0, then the output will be 1. And you can rewrite completely all of the segment here. So this is our experiment has been complete. There is a student work here, that the output of an AOI, that means AND or inverter gate, is A prime B prime plus C prime D prime. What is the output of C if C is equal A prime and D is equal B prime? Okay, so if you want to clear this question, make sure that you have easily understand our previous project. This is very easy. Okay, thank you for this experiment. Assalamu alaikum.